It's your first time, eh?
Yes.
You have professors?
Yeah, Professor Chuku.
Professor Chuku. He has been able to check your work up to that level?
Yes.
Yeah?
Yes.
Okay. So we are interested in your objectives, method, and so on. Just proceed.
6:29, eh? The next, how many minutes? Under 10, eh? Is it the first time?
Yes. Good afternoon, my name is Gabriel. So my topic, investigation on the impact of mango, macadamia seeds fiber reinforcement, and the mechanical strengths of that polymer native manufacturing for circular economy application. As an introduction, Hdpe is a polymer which is petroleum-based thermoplastic. It is considered to be sustainable. It is eco-friendly, even if it is a plastic, because it is used, it has recyclability and chemical resistance. It is not easily attacked with chemical compound. Above from that, it can resist, it has melting point of 120 to 130. It is used in fused deposition modeling, 3D printing. Its use is poor, is limited by poor interlayer bonding and moderate mechanical strength. But the reason why we add fibers is to work on mechanical properties. Agro waste, as mango seeds and macadamia shells, is abundant and underutilized. So these fibers, when we are talking about fibers, this is one of the sample. We will be able to mix it with that polymer at some percentage so that we can get strength and fracture, even impact. Problem statement: large volumes of mango and macadamia agro waste are inadequately and remains underutilized. Limited studies focus on food waste fibers in that polymer for 3D printing. Unclear optimal fiber ratios for balancing strength and printability. We will see in methodology that we need some ratios for optimization. Optimal fiber ratios for mechanical performance and printability is not well established. The problem statement, most of us will know PRA and other polymers, they are most used. And some fibers like hemps, sisal and others, they are commonly used. But for problem statement, these mango seeds is not commonly used. That's why it is limited. We are finding out. Objective is to investigate the effect of mango and macadamia fibers. Specific, we shall need to extract and treat fibers using chemical treatment so that the bonding interface, we can have a good bonds. Develop fibre-reinforced Hdpe filament for our main purpose is to come up with a filament. It will be having 1.75 millimeters, which can be able to Our focus is to get a filament which is able to do all the work. Some literature reviews, some people worked on mango shell. Also alkali treatment, but we use that sodium hydroxide, of course in some temperature of 60 Celsius, and some 4 hours as soaking. Before we do the complete fabrication, we need that treatment so that our composite can be okay. We have a lot of literature reviews, but let me learn to methodology. Research gap: limited comparative studies between mango and macadamia fibers in Hdpe. Few investigation on these fibers in 3D printing. When you are reading literature reviews, this is not a common, it has been not used, so that is the research gap. Optimization of fiber ratios for strength and printability remains under explored. Methodology, let me go in details. We will have materials, this pellet as matrix. We will have reinforcement as the seeds. We will have sodium hydroxide in treatment. We will have distilled water for neutrality. Equipment, we will use mechanical grinder. There is a hammer mill here in mechanical lab. We have dryers. I went to JQuat, they have these dryers. And they have that screw extruder. We will be able to make that filament. 3D printer, we will also need it. And some preparation. We have to clean this with a lot of water so that now it is clean, it is not mixed with sugars. So after this, we are removing contaminant. I put it on sun and even oven, grinding them using the hammer to make it final particles, because you know when particles are very fine, can make a good bonding. Then treatment. Then we go to combining them. We shall have like 5 samples. To have a good strength, we are supposed to, our fibers, the challenge of this, when the percentage is beyond 20, we have weak composite, but our range is between 0 to 20. Especially for mango. For macadamia, 10 to 20. So we'll try to have these fiber loadings so that we see how we can come up with that filament. Filament will be having 1.75 millimeters. Filament sprayed and inspected is there in JQuat. 3D printing. We shall use the position modeling process. Of course, it has a lot of procedures. We shall control temperature of nozzles, also speed. Testing for tensile test, to be honest, we will be able to do 2 tests, tensile and flexural tests. But this one down, I can do modeling, but from the advice, they say we can do those 2. The ratio, fiber loading, we'll do that sample so that we can see, because this investigation, we may find at some percentage it is going weaker or it is increasing, because our focus is to investigate. Circular economy, reduction of plastic only material usage. support industrial symbiosis, aligns with circular manufacturing. Expected result: tensile strength, it is expected to increase. When you have a net polymer, it is varying to 25 to 33 MPa, but when it is a composite, of course it has to increase. That strength, flexure strength, we shall use 3-point bending. Also it is expected to increase. For impact, we will not be able to do it. Net polymer, Hdpe, for it has low stiffness but high ductility. But when you mix it with fibers, we will expect higher strength and stiffness. Improved load transfer due to fiber reinforcement. So our budget, in my proposal, I started writing proposal. I have a table, but here I try to do summary. I went to check what they are saying, which will go below that one. Work plan, according to supervisor, is willing to finish in August, but I gave it 12 months. Proposal, literature review, this one we have started working on them. Correction of mango, we already have them, we are drying them. Cleaning. Yeah, this is the steps. For the sake of time, by September, we shall be able to test tensile and flexural. For water absorption, this polymer is able to resist water and moisture. So we can apply it to some humidity, but our interest is those two tests. Conclusion: this study addresses plastic and agro-waste challenges. Natural fiber reinforcement offers mechanical.
Conclusions come later.
Okay.
Able to get what we required. So we can have comments. Number one is your work plan. Why you intended to take 1 year?
When I was reading literature reviews, some related topic, it is taking 16 months. So I wish it can go less. I wish.
6 months? Don't you wish? You cannot plan your work in 6 months.
I can.
Because it is mostly the recommended research duration. Can you tell us documents that means you may be able to inform us? Or you have agreed with your supervisor to go that way? Because the rest of the work, what you have presented, apart from mostly the work plan, the rest appeared to you have worked with your supervisor. Appeared clear what you are saying, even your objectives are presented. Some elements which are very clear. But now when it comes to the work plan, did you work with him or you worked alone?
For the work plan, okay, he was advising me. By May, we are done with.
That's correct. This is the 6 months I'm talking about. So in summary, we agree there is some work and we have made some progress with the proposal.
Thank you.
Can you give